All right, what's going on, guys? Make sure you have all of these notes in the back of your quiz paper. So quick notes, stuff that we've already done before in the rest of the year. Here we go. Make sure you write down this section. See how big my sections are? They're like, this is going to be your whole paper. Like half the paper will be your whole back paper. So make some boxes about this size. Here we go. Rational numbers, what are they? Rational numbers are, remember the word rational? We can turn into fractional. So anytime you can make a fraction out of a number, it is a rational number. So here we got three rational numbers. How do you turn decimals into fractions? Well, over here on the other side of my paper, I'm just going to go 9 divided by 16. Oops, come on. 9 divided, let's go. 9 divided by 16 is 0.5625. So that's 9/16 as a decimal. You just put it in your fraction. That's just division. Now, if we do turning decimals into fractions, 0.32 is really easy. We know that's the 10 spot, that's the 100 spot, that's 32 100ths, but we can never have two even numbers in our fractions. We cut them in half, 1650. There's still even 8/25 is my fraction for 30.32. Now, if they have a repeating line over it, this means it's 0.323232, and both numbers repeat over and over and over. We know this is the tens and the hundreds place, and it's a perfect. It goes all the way back to the decimal. So we just take one off the bottom, and this is 32/99. They're both not even. 3 doesn't go into both of them. This is exactly as far as we can go. Now, what happens when the line doesn't go back the whole way? We still go, okay, 10, 100 spot. This line doesn't go over the 3 in the 10 spot, so it would be 32 over 100. We subtract the 3 from here. We subtract the 10 because the line didn't cover those. And we've got 29/90ths. And there we go. We're done with those. So rational numbers are pretty much anything that you can make fractions out of. So some other things I want on your paper, I want that you know that pi is not rational because it goes on forever, not repeating. The square root of 15, not rational because it goes on forever repeating. Anything that has a square root in it, not one of our perfect squares, not rational. Normal numbers, 4, like 6, 11, yes, those are rationals because you can just put a 1 on the bottom. And the only other thing they might try to get you with is like square root of 81 is rational because that can just turn into 9, which is just any number we can put a fraction on. So rational means fractional. Okay, let's go over to like our exponents and powers rules. Remember, our powers rules are our power down rules. So anytime we're dealing with power, we do one level down. If there was like a building on the bottom, we teach kids addition and subtraction, or actually, sorry, on the very bottom level is nothing. When you come into school, you know nothing. What you learn at the beginning of the school year is addition and subtraction. After that, you learn multiplication and division. And after that, finally, you learn powers. So when we're dealing with powers, we always do one thing, one level less. That's why we call it power down. So over here, when I think of one level less than addition, sorry, there's no shortcut there. It's not no solution, just no shortcut. So this one would just still be x to the 6th plus x to the 2nd. What's one less than subtraction? One less than subtraction, nothing, no shortcuts. It's still x to the 6th minus x to the 2nd. Okay, one less than multiplication. One less than multiplication. Well, over here, one less than multiplication, we go down one is addition. Okay, so I just add the powers, and this is x to the 8th power. Okay, one over here, one less than division is subtraction, so this is x to the 4th. Now, do you remember what negative powers meant? Negative powers, if we have x to the negative 3rd, all that means is that we make it a fraction. It means we're not multiplying x times x times x, we're dividing x by x by x. So basically, what you can do is turn it into a normal power, but you have to make it a fraction. So if that was a number, if that was like 2 to the negative 3rd power, then we would make it 1 over 2 to the 3rd power, or 1 times over 2 times 2 times 2 is 8. So 2 to the positive 3rd power would be 8. 2 to the negative 3rd power is 1/8, not negative 8. Something to remember. Okay. On some problems like this, they'll have us work backwards. We know this is division. So one less than division is subtraction. So we see the same base. We see this is both powers of 3. So we would subtract x minus 2 equals 4, because that's our answer. So what did x have to be to start off, so that when you divide it by 2, or power down, you're really subtracting? What did x have to be? Hopefully you know what that is. Okay, and then finally, the very top level is powers. 1 less than powers is multiplication. So whenever we're doing powers, we just multiply. This is powers of powers. So 1 less than powers is multiply. This is x to the 12th power. Now, down here, we do the same thing. Anytime we do normal numbers, that's easy. We don't use power down rules. We just do it. 2 to the 3rd power is 2 times 2 times 2 is 8. And then we use the powers rules here. So this is 3 times 3. This is 8x to the 9th. So 1 less than powers of powers is going to be multiplication. Okay, so those are the basic ones, but what happens when it's advanced? What happens if we have something like this where we're multiplying? You can see right here we have this parentheses, which means multiply. How do we do this? When there's these long ones. We did this before, where with normal numbers, we don't have power down rules. We just do -7 times 5 is -35. We only use the power down rules with powers. Now, a to the 4th times a to the imaginary 1. Anytime there's not a power, it's imaginary 1. We add the powers because 1 less than multiplication is addition. And this is a to the 5th. B to the 1st times b to the 4th is also b to the 5th. And c to the 3rd times c to the 2nd is c to the 5th. So you just, basically, it's a lot of problems into one problem. Now, is it really that hard? No, you just follow the rules and turn it into one big number. Same thing with division. They might throw a lot at you at the same time. Okay, let's see. 9 divided by 3, we just do that like normal numbers. 9 divided by 3 is 3. Now, 3 could be 3 with a 1 on the bottom, so 3 is on the top. We don't write the 1, though. Okay, so then we just go letter by letter. X to the 6th divided by x to the 4th. I could think of the 4 on the bottom, canceling 4 of these out on the top and making just x to the squared. But x to the 6th minus x to the 4th is still x to the 2nd power. We're just doing subtraction. And over here, 1 less than division is subtraction 2. And we have y to the 13th. All of these things canceled out on the bottom. So we really have a 1 down there, but it's basically gone. And we have 3x squared y to the 13th. So we just took it one at a time. The normal numbers, we do not subtract. Normal numbers, you do normal division. The power down rules only works with numbers with powers. So don't say 6. Don't say 9 divided by 3 is 6. With normal numbers, just do normal division. Over here, same thing. -5 to the 4th power is negative, let's see, that's 5, let's see, 5 negative times 5 negative times 5 negative times 5 negative. 5 to the 4th, -5 to the 4th power is 625. Now we have powers of powers. 1 less than powers is multiplication, so that's r to the 16th. And then for 1 less than powers of powers is multiplication, so that's s to the 48th. So sometimes these things can get long, but it's just the same. It's just like putting multiple letters together. It's just like these, but maybe more than one problem at the same time. All right, and then finally, things that we did this year. Equations of lines. For most of our class, we did slope-intercept form, where y equals mx plus b. What did that look like? That looked like maybe like y equals 2/3 x plus 4. That's what we did all year for an equation of a line. This m right here, that's the slope, right? We always know where to find the slope. And this b right here, we called it the y-intercept. That's the starting spot. So if you ever say, hey, what's the form of that we always graph? It's called y equals mx plus b form, or slope-intercept form. Now, I could take this equation and rearrange it and put it in standard form. I could like throw the 2/3 x to another side and make it -2/3 x plus y equals 4. All I did was take the x's and move them to the left, and when you move them to the left, they become negative. But then you're not allowed to have a fraction in standard form, so I'd multiply everything by 3. So they would get rid of the bottom and have -2x plus 3y equals 12. So same equation, I just rearranged it. And this is standard form. What this actually looks like is some number with an x plus some number with a b with the y equals some number. And those numbers can't be fractions. No fractions in this form. So it's the same thing, it's just rearranged. And then for my honors class, we had something called point slope. You remember that? Where like, and for you guys, other people who don't know what it is, still copy it down. It's called point slope form. These are all the same things, but just in different forms. Now, let's say I know the slope of a line is 1/2 and it goes through a point 3.7. Now, that's enough information to write an equation. What that would look like is you go y minus whatever the y is. So right here it's 7. Y minus 7 equals, you put the slope in, and you could put x minus whatever the x is, and the x is 3. So we say x minus 3, and we're done. There's an equation of a line. Perfect. Why do they call it point slope? Because you can see a point right here, 3.7, and you can see the slope. So that's, in my honors class, that's a really easy way to do another equation of a line, but you have to know the names of these. Slope intercept, y equals mx plus b. You have to know standard is just like something with an x plus something with the y equals c. And then point slope, that's kind of for my advanced class, but if you can memorize